Welcome, geometry students, to class today. Hope you guys are doing well. Hope you're ready to learn some math today. Hope your week has gone well for you so far. Please work hard in class today. We have today left, Thursday, and then tomorrow, Friday, and the weekend will be here quickly. So please work hard. This video will be long today, I want to warn you, and so be prepared for that. However, there will not be any homework tonight. Tomorrow, we will spend the entire class period working on homework that will cover the material that I taught in class today. So, long video today. Please pay attention, work hard, do a good job. If you do not finish, well, when I say there's no homework, there will be a copying assignment. But I don't really count that as homework, and it's only 2 little definitions. But moving on, if you do not finish the video in class today, then you are required to finish it tonight. Please call or email if you have any questions at all. Okay, announcement number 1. There will be no quiz this Friday, so I know that probably just brightened up your day a little bit. No quiz tomorrow. We're going to do that next Wednesday. I forgot that Mr. Harmon told me the best days are Monday, Tuesday, and Wednesday for him. I think that's because of the computer lab. And by the way, speaking of the computer lab, it's my understanding we have that problem taken care of, and you guys will have headphones and your own personal computer. So if that's not the case, please contact me and I will definitely work on this, okay? And then lastly, your homework should be done. If you didn't do it, I'm sorry, but I will be checking my box today at the end of the school day today, Thursday, and I will be contacting parents if your homework is not turned in. Please do your homework, okay? Well, let's get started, shall we? Grab your notebooks, your pencils, your calculators, your books, everything that you need, and please give me your undivided attention. By the way, today's material is really important, and that's why I'm spending a lot of time on it. I'm going to go slow today and give you a lot of examples, and then I'm giving you the whole class period tomorrow to work on your homework. There will be times today during the video that you will have to pause the video and copy things down. Let me get a drink of water here. And let's go ahead and get started. Here we go. If I can get my mouse to work. Here we go. Okay. All right. We're going to look at a topic today called similar polygons. Please write that down. Similar polygons. The lesson number is 7.2. And the date today, which I encourage you to keep track of, is the 9th, January 9th, 2014. Now, we have looked a lot at congruent polygons, specifically congruent triangles. And I want to say right off the bat, right now, please listen to me, congruent triangles or congruent polygons are not the same thing as similar polygons. There is a difference, and we're going to look at that difference today, actually right now, okay? So please copy this in your notes, similar polygons. The date today is the 9th, and here we go. Please copy these 2 little polygons, or first of all, copy this definition in your notes. You're responsible for this on quizzes and tests. Similar polygons are polygons that have congruent corresponding angles and, look at this, proportional, not congruent, proportional corresponding sides. Let me read this again. Similar polygons are polygons that have congruent corresponding angles and proportional corresponding sides. Now, I'm going to explain what that means in just a second. In fact, I'm going to give you a really good picture of what that means in just a second, okay? But copy that definition in your notes. Now, and again, you'll have to pause the video a lot today. I'm going to move on. You can always you can always slow me down, but you can't speed me up, so I'm going to move on. All right, now, copy these 2 polygons in your notes. Please notice that these 2 polygons are what we call congruent. They are not similar. How do you know that, Mr. Hart? Well, I'm glad you asked. Notice we have this side congruent to this side. We have this side congruent to this side. We have this side congruent to this side. And we have this side congruent to this side. So, are all 4 sides congruent? Yes. Notice this angle is congruent to this angle is congruent to this angle, etc., etc. Are all 4 angles in this polygon congruent to all 4 corresponding angles over here? And the answer is yes. You learned this probably 2 months ago. whenever all of the angles and all of the sides, of course, corresponding angles and corresponding sides of two polynomials are congruent, then the two polygons, I think I said polynomials, sorry about that, whenever all of the corresponding sides of one polygon are congruent to all the corresponding sides over here, and all of the angles are congruent to the corresponding angles over here, then the two polygons are congruent. They are congruent. So what is similar polygons? Well, I'm glad you asked. Please copy this down. Please copy these two polygons in your notes. Let me grab a drink of water here. Copy those down, please. Now, there are two things that you must have. Are you listening, guys? There are two things you must have in order to have similar polygons. First of all, you must have what? Congruent angles. So far so good. Check mark here. Congruent to this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. Cool. Very good. The second thing we must have are proportional corresponding sides. Mr. Earhart, what do you mean by proportional? Well, I mean that they increase by the same multiple. For example, this side here increased from a 3 to a 6. That means we multiplied this side by what? 2. This side here increased to what? 4. That means this side was multiplied by what? 2. Do you see that? 3 times 2 is 6. 2 times 2 is 4. This side here was increased to 6. That means I multiplied this side by 2. And this side here was increased to 4. That means I multiplied it by 2. Do you notice something? Did we not multiply every side by the exact same number? Sure we did. That means you have proportional corresponding sides. You increased all the sides by a multiple of what? A multiple of 2. So let's go over this again. There are two things you must have to have similar polygons. The angles have to be congruent, and they are. Now, by the way, it doesn't mean all four angles have to be the same, like 90, 90, 90, 90, 90, 90, 90, 90. That's just a coincidence, okay? This is probably not the best example to use. But each individual angle is congruent to its corresponding angle over here. And secondly, the sides are proportional. In other words, they were increased by the same multiple. Do you see that? All right, now let's continue on. I would like you to copy this example in your notes, and let's just talk about it for a second. I just want to show you something, okay? Oh, by the way, I apologize. I should have showed you. Just like this is the symbol for congruent, right? We've learned that. Well, this is the symbol for similar. This is the symbol for similar. So when you see that symbol right there, it means this triangle is similar to this triangle. Now, I just want you to copy this in your notes. It's not a problem we're going to work on. There's nothing we're going to do to this. I just want to discuss this with you, so please watch, okay? Notice how this angle here is congruent to this angle here. Notice how this angle here is congruent to this angle here. And notice how this angle here is congruent to this angle here. Do you see that? And that's good. Whenever you have what? Similar polygons, in this case they're triangles. Whenever you have similar polygons, all of the corresponding angles have to be congruent. I just want to give you another example of what similar polygons look like. Do you see that? And then the second thing is we have to have proportional corresponding sides. So this side increased from a 6 to a 12. That means I used a multiple of what? 2. 6 times 2. This side here increased to what number? 14. That means I used a multiple of 2. And this side here increased to 8, and that means I used a multiple of 2. So I'm just trying to give you another example of what similar polygons look like. It is so important that you understand this concept today, because you will be I'm not being mean. You will be lost the rest of the chapter if you don't grasp this. So let's go over it again. Angles have to be congruent. Corresponding sides have to be proportional. They have to be increased by the same multiple. So here's another example of similar polygons. Angles are congruent, sides are proportional. Now, let's go ahead and start working some problems, and let me teach you some different things you need to know. Please copy this in your notes. Copy down triangle STU and triangle PRQ. Copy these down. I'm going to move on. If I'm going too fast, just pause the video. Let's check and see if these two triangles are similar, shall we? Here we go. Step 1, make sure all of the angles are congruent to each other. All right, let's see. This angle has 2 slashes, and this angle has 2 slashes, so that's good. This angle has 1 mark, this one has 1 mark, so that's good. And this angle has 3 marks, and this angle has 3 marks, that's good. So, are all of the angles congruent to each other? Yes. So far, so good. Let's continue and let's see if these two triangles are similar. Make sure the corresponding sides are proportional. Oh my goodness, this is going to be a little harder. Look, now watch this, please, students, watch. If this was a 16 right here, then it would be easy. That means we increased from 8 to 16, and that's a multiple of 2. But we don't have 16, we have a 10. So this is not going to be as easy. So can I please show you what to do? Whenever you don't have multiples that are easy to figure out, like 8 times 2 is 16 or 8 times 3 is 24, then do this. Take this side here. Now watch, take notes on this. Take this side here and put it over its corresponding side. It's a fraction. And then take this side here, 16, and put it over its corresponding side. And then take this side here and put it sorry, excuse me, and put it over this side here as a fraction. And then reduce all of your fractions. And if all 3 fractions are equal after you've reduced it, then we know that the two triangles are similar. So let's see what happens. Let's reduce 8/10 and we get 4/5. Let's reduce 16 over 20 and we get 4/5. And let's reduce this by 3 and we get 4/5. So 4/5 equals 4/5 equals 4/5. Okay? And so did all 3 fractions end up being equal? Yes, they did. So that does mean the corresponding sides are what? Proportional to each other. Now, you didn't know how to do that until now, so take a look at that, rewind it, and watch it again if you need to. Let me get a little drink here. You've got to know how to do that. That's why I'm spending 1 day in the video and no homework tonight and then homework tomorrow. I'm trying to go slow on this, okay? Now watch. So what does this 4/5 mean? It just means this. It just simply means that if you took this side over here like 10 and multiplied it by 4/5, you would get 16. Trust me, if you want to take your calculator and check it, feel free to. If you take 10 times 4/5, you will get 8. If you take 20 times 4/5, you will get 16. If you take 15 times 4/5, you will get 12. So in other words, the multiple was 4/5. Now you don't need to know that right now. I'm just trying to show you how this works. The main thing I want you to see is when you have some really weird numbers like 16 being changed to a 20, and it's really hard to see what the multiple would be, like 16 times 2, 16 times 3, then use this method here. Take each corresponding side and put them on top of each other, over and under, like a fraction. Then reduce all of your fractions. And if all of your fractions are equal, then you know the two sides are proportional. You know all of the sides are proportional. Now, were all the angles congruent? Yes. Are all the corresponding sides proportional? Yes. So we know that these two triangles are similar. So go ahead and put your little mark right here. These two triangles are similar. Now let me teach you some more stuff, contain your excitement, I'm sure, that you don't know how to do. Number 3, let's learn how to write a statement of proportionality. Now look, listen to me. You cannot write a what? A statement of proportionality unless the two polygons are what? Similar. Now we know these two triangles are similar because we just proved that. The angles were congruent and the corresponding sides were proportional. But sorry about that. If now we are going to write a statement of proportionality, then we have to have two similar polygons, and we do. So let me teach you now how to write a statement of proportionality. Please pay attention. See side TS right here? TS? Do you see that? Well, it corresponds to RP. So you put TS over RP. That's easy. And then see side TU. Well, TU corresponds with RQ. And SU corresponds with PQ. So SU over PQ. And then write this. Equals. There, that's it. It's that easy. If you'll just learn it and memorize it and know how to do this, it's not that difficult. So you just learned how to write a statement of proportionality. That's it. That's your answer. Now, Mr. Earhart, what if I would have put RP over TS? I have no problem with that. You could have put RP over TS equals RQ over TU equals PQ over SU. Do you notice how I flipped every fraction? I have no problem with that. Either one, and neither does any math teacher. That's totally fine. Either one of these two statements are called a statement of proportionality. Okay? And it makes sense. We have proportions right here. Ratios set equal with equal signs. Okay. Now, let's take a look at one more thing. I want to teach you how to write a similarity statement. You need to differentiate between the two. One has the word proportionality, one has the word similarity. When I ask you to write a statement of proportionality, it's going to involve having proportions like this. When I ask you to write a similarity statement, it's going to involve a similar symbol like this. Now, here's all we do. It's so easy. I say triangle TSU. Please write that down. Well, Mr. Earhart, could I use STU? Sure. Could I use SUT? Sure. UTS? Yes. UST? Sure. TSU? TU? It doesn't matter. It doesn't matter what order these first three letters are, but it does matter what order these three letters over here are. Because if you put T first, what angle corresponds with angle T? Angle R does. So if you put T first over here, you got to put R first over here. Next, you put an S right here. So if you put an S, angle P corresponds with S, so P has to come next. And then, of course, angle U corresponds with Q, so Q has to come next right here. Okay? So these three letters right here, whatever order you write them, dictates what order these three letters will be over here. So there, you did it. Do you see the difference? This is called a statement of similarity or a similarity statement. Okay? And this is called a statement of proportionality. They're not hard. You just got to know how to do it. Let's practice again and again. Let's really get this. Then we're going to go on to what a scale factor is. All right? Let me get a quick drink of water here. And let's continue on. Here we go. Okay, let's see if these two polygons are similar. Now I'm going to move on. If you got to pause the video, feel free to do that. That's fine. I'm going to move on. Number one, let's make sure the angles are congruent. Well, let's see. 1 mark, 1 mark, that's good. 2 marks, 2 marks, that's good. 1 mark or a right angle and a right angle, that's good. And 3 marks and 3 marks, that's good. So I want to check and see if these two polygons are similar. And there's two things I have to check. Number one, are the corresponding angles congruent? And number two, are the corresponding sides proportional? So here we go. Now, yes, all of the angles were congruent. Now let's make sure the corresponding sides are proportional. This is not going to be easy, guys. You change the 2 to a what? 3. Now, if this would have been an 8, that's easy. You know it would be 2 times 4, and you would check to see if all of these sides had been multiplied by 4. And if so, then you have similar polygons. But this is a 2 and a 3. This is weird. So let's use the method that I taught you on the last problem. Are you ready? 2 goes with 3. So I'm going to write 2 over 3. 2.8 goes with 4.2. They're corresponding sides. So I'm going to put 2.8 over 4.2. Well, 4 corresponds with 6. So I'm going to put 4 over 6. And then 2 corresponds with 3. So I'm going to put 2 over 3. Now let's reduce all of these fractions and let's see what we come up with, okay? Well, 2/3 cannot be reduced. This looks really hard. Let's save that for last. 4/6, if we reduce it, we get 2/3. And then over here we have 2/3. Now, most of your calculators will reduce your fractions for you. For example, if you have a TI grapher, all you have to do is hit 4 divided by 6. Got it? Then hit enter. That's the symbol for enter. Hit enter, and then hit math, enter, enter. And it should pop up 2/3. Now, I don't know about every single calculator that's out there, but I'm just addressing those that have a TI grapher. But you really don't have to use that. I mean, it's pretty obvious. I mean, we can reduce fractions in our head. Now, this was a little more difficult, but can I please show you an old trick of the trade? Whenever you have a decimal here, you're welcome to move a decimal in a fraction. You are, Mr. Hart? Yeah, you can move a decimal as long as, however many places you move it up top, you move it the same places in the bottom. So I'm going to move this decimal one place, so now I have 28. But if I move the decimal one place in the top, I must move the decimal only one place down here. And I do, and I get 42. And now, let's think about what numbers go into this evenly. Let's see. 7, yes, 7 does, and there might be a bigger number than 7. 14 actually. 14 goes into both of these numbers. 14 goes into 28 2 times, and 14 goes into 42 3 times. So 28 over 42 reduces to 2/3. Now, if you want to use your calculator, simply type in 2.8 divided by 4.2 with your grapher, and then hit enter, and you'll get some decimal number. Then hit math, enter, enter, and you'll get 2/3. So I have a question for you. Are all 4 fractions equal? Yes, they are. If just one fraction wasn't, then we would not have proportional corresponding sides. Thus, we would not have similar polygons. So, but in this case, all of the fractions did reduce to equivalent fractions. So I know that I have, sorry about that, did not want to do that. So I know that I do have similar polygons. So they're similar. All right, let's continue on. Let's write a statement of proportionality. Okay, here we go. Side JK corresponds to side NP. Then put an equal side. Side JM corresponds to side NR. Side ML corresponds to side PQ. And side KL corresponds to side PQ. All right, and I think I made a mistake right here, and I'm sorry. This should be RQ. Sorry about that. ML, I need glasses. ML corresponds to RQ. So there's your statement of proportionality. Not hard. Now let's write your similarity statement. So we have polygon J, K. Actually, we'll go clockwise. You have polygon J, M, L, K. Similar. Now we put J first over here, so we have to put N first, and then M is second, so we have to put R second over here, and then third is K, and so next would be P, and then, or excuse me, next is L. I apologize. So next would be Q. And then next over here is K. And so the angle that corresponds with K is P. So next would be P. There we go. There is a similarity statement for your two polygons that are similar. Guys, I hope you're getting this. You have to know how to do this. You have to know how to prove that two polygons are similar. The angles have to be congruent. Corresponding sides have to be proportional. And then number three, you have to know how to write a statement of proportionality. And number 4, you have to know how to write a similarity statement. Now let's go ahead and continue on. I want you to write this definition in your notes. You're responsible for this. I want you to write, and thinking of it now, I don't think the other night when I gave you homework, I don't think I made you write your definitions 2 or 3 or 4 times. So that was my fault. I forgot, but I will get back into the practice of that. But I want you to write this down. Scale factor. What is a scale factor? It's the ratio of the lengths of 2 corresponding sides. It's the ratio of the lengths of 2 corresponding sides. That's what a scale factor is. Okay? All right, let's continue on. It's the ratio of the lengths of 2 corresponding sides. Now, let's take a look at these 2 triangles. Copy this in your notes. Again, I'm probably going too fast. Just pause the video, copy this down, then turn it back on. We have triangle GHJ is similar to triangle MKL. Now look what I want you to do. Follow this carefully, okay? I want you to find the scale factor. Now watch this, of triangle GHJ to triangle MKL. Now which triangle comes first is very important. So always be careful. Read the problem carefully, okay? Don't just assume that the triangle here, this triangle right here, is always going to be first down here. That's not always true. Okay, so be careful. We're going to find the scale factor of triangle GHJ to triangle MKL. So here's what we do. We pick any side over here that we want to. This is how you find the what? Scale factor. You pick any side over here you want to. For no set reason, I'm just going to pick this side right here, HJ. All right, and that would be 12. Now what side over here corresponds with HJ? Well, this side does, and its length is 16. That's it. It's that simple, guys. Now you take that fraction and reduce it, and you get 3/4, because 4 goes into 12 3 times, and 4 goes into 16 4 times. There's your scale factor. Now the only thing I'm worried about is you guys not paying attention to what triangle came first right here. Okay? Since GHJ came first, then notice the side from this triangle, 12, went up top. This first triangle here has to have the side go up top. The second triangle here has to have the side from the second triangle go in the denominator. That's very important. Or you're going to get 4/3 for an answer, and that's not true. 4/3 is not the scale factor of triangle GHJ to triangle MKL. The scale factor of triangle GHJ to MKL is 3/4. Okay? So that's simply it, okay? That's the scale factor. Now, in other words, that's the multiple that's being used when you multiply this side here to get this side over here. All right? Okay. Now let's take a look at another problem. I want this in your notes, so please copy this down. I'm going to move on, so if you have to pause the video, that's fine. Now look how I'm trying to trick you here. Look how I'm trying to trick you. Find the scale factor of triangle MKL to triangle GHJ. Now this triangle is first in the picture here, right? But in the problem, I'm asking you to find the scale factor of MKL to GHJ. So since this triangle here came first, MKL, I'm going to choose the side from this triangle over here, MKL. Doesn't matter which side, I'm just going to choose this one. It doesn't matter. You'll get the same answer either way as long as the two triangles or the two figures are similar. So, because MKL came first, I'm going to pick a side from MKL. I'm going to write it right here. And then GHJ, triangle GHJ came second, so I'm going to put the corresponding side from over here. What side goes with ML? Side GJ, 15, that'll go in the bottom. And now we simply reduce that by 5, because 5 goes into both of those numbers, and 5 goes into 24 times, 5 goes into 15 3 times. And there is the scale factor of triangle MKL to triangle GHJ. That's it. It's not that hard. It's a lot to learn, yes. And that's why I'm teaching you today. And I'm giving you all class period to think about it. And then tomorrow, instead of throwing new material at you, we're going to spend the day tomorrow practicing this in homework, okay? All right, now let's review. Let me get a drink of water here. Let's review. This is not optional. Notice how I'm making it a little more difficult. I've twisted the one triangle over there. Okay, they're not facing the same direction, so really pay attention. Copy these two triangles in your notes. I'm going to move on. If you have to pause the video, that's fine. Okay, number one, are these two triangles similar? Well, I don't know. Let's see. I have a congruent, let me get a different color of ink here. I have this angle congruent to, I have this angle congruent to this angle, so that's good. I have this angle congruent to this angle, that's good. And I have a right angle congruent to a right angle. That's good. So all three angles are congruent to all three angles over here. Now, next I have to check my proportionality. Now make sure you line up corresponding side with corresponding side. For example, see this side right here I'm putting a squiggly line on? Notice how it has an angle with one slash and an angle with 3 slashes or 3 marks. Do you see that? So the corresponding side over here has to be a side that has 1 mark at the end and 3 marks at the other. Well, that's this side right here. Do you see that? So 26 goes with 39. So if I'm going to check to see if these sides are proportional, then I've got to write a fraction. So 26 over what? 39. Okay, let's continue on. Now look at this side here. Notice this side here has a right angle for one angle and 3 marks for another angle. So I'm going to come over here and find the side that has a right angle and 3 marks. And it's this one. So this side right here, 24, corresponds to this side here, which is 36. So I'm going to put 24 over 36. Now, I've got one more side to check out, and that's this side right here, and the 10. And the only side I've not used over here is 15. So 10 corresponds to 15. So 10 over 15. Now I'm going to reduce all of these fractions, and we're going to see if we get the same fraction. 13 goes into both of these. 13 goes into 26 twice, and 13 goes into 39 3 times. 12 goes into both of these. 12 goes into 24 2 times, and 12 goes into 36 3 times. And then 5 goes into both of these numbers. 5 goes into 10 2 times, and 5 goes into 15 3 times. So I have a question for you. Do all three of these fractions equal each other? Of course. So are all of these sides proportional to their corresponding sides? Yes. So we checked everything. Are these two triangles similar? Yes. Were the angles congruent? Yes. Were the corresponding sides proportional? Yes. So let's continue on. Can you now write a similar statement on your own? A similarity statement? Well, I hope you can. It's not that hard. I better put some letters up here though. Triangle ABC, triangle DEF. Yes, my voice cracked. Sorry about that. All right, let's write a similarity statement. So I have triangle ABC is similar to triangle. Now, you could have put these 3 letters right here in any order you want. It doesn't matter. I chose ABC. So I put A first. Here's A. The corresponding angle would be E. So E has to come first. My second letter is B. Angle B has 1 mark. The corresponding angle is F. So F has to come next. F. And then the only letter I haven't used over here is D. So there, you did it. You wrote a similarity statement. Now, can you write a statement of proportionality? Well, I hope so. In the last problem, this is the same problem. In 2 steps ago, we saw that 26, I better put letters on here again, A, B, C, D, E, F. There we go. Sorry about that. Okay, in the last problem, we saw that this side here corresponded with this side here. Okay, we saw that not in the last problem, but 2 steps ago, right over here, when we wrote all of our fractions. Okay, so we saw those 2 sides are corresponding, so I'm going to put BC over DF. And then the last problem, we saw that 24 and 36 were corresponding sides, so we're going to say AC over DE, they're corresponding sides. And then the only sides left we haven't used would be side, you could put AB or BA, it doesn't matter. Side AB corresponds with side EF. And then you put equal signs between all of them. There you go. You wrote a statement of proportionality. Good job. Well done. And now, last but not least, I want you to find the scale factor of figure B to figure A. Well, I'm going to call this figure A, and I'm going to call this figure B. Find the scale factor of figure B to figure A. Okay, now which figure came first down here in the problem? Figure B. So I'm going to pick one side. It doesn't matter. Just pick one side from over here. And why over here? Because what came first in the problem? Figure B or figure A? Figure B did. So you go to figure B first and you pick one side. I have no reason. I'm just going to pick this side. I feel like it, so there we go. So you write a 15 up top. Okay, find the scale factor of figure B to figure A. So now in the bottom right here, I've got to write the corresponding side, or the side that corresponds with 15 from figure A. Well, the side over here that corresponds with 15 is this side here, 10. And now reduce it and you'll have the scale factor. The scale factor of figure B to figure A is 3/2, 3 over 2. And there you found the scale factor. It's that easy. Okay? Now please, please, please call or email if you have any questions. I hope you're getting this. This is the homework you will do tomorrow in class. Yes, it's 28 problems, but you'll have the whole class hour to work on it, and I think you'll finish most of it, if not all of it. There's something else, though, I want you to do on this homework assignment. You can start it tonight, but you don't have to. I want you to copy your pretty sure it was 2 definitions. Let me go back and look real quick. I want you to copy similar polygons. That's one definition. And I want you to copy scale factor. So I want you to copy those 2 definitions 3 times each. Definition of, I'm going to write sloppy here, similar polygon, and definition of scale factor. Write each of those definitions 3 times each, along with this. Now, none of this is due tomorrow. Do you understand that? None of this is due tomorrow. You're going to work on it in class tomorrow and turn it in on Monday. Now, if you want to get a head start tonight, I have no problem with that. Knock yourself out. Feel free to do that, but you don't have to. Okay? Have a great rest of the day. Hope you guys are doing well, and I will talk at you tomorrow.